All right, so the concept of translation softwares is actually continued from AS level. Okay, so translation softwares. So translation softwares can translate, okay, interesting, translate to interpreters and compilers. This is pretty much like the basics of, like the A-level knowledge. Interpreters have the following features. Uh, they can translate line by line only. Doesn't produce executable files. Suitable for development or the development period while you're actually making a program. Compilers produce exe files. Can translate at once. Any error reports will be produced at the end. Errors are at the same time they are identified. All right, so these are pretty much about translation softwares. Then we also learned about something called partial compilation and interpretation. So interpretation and partial compilation, they allow code to work on any machine. It's like a standard set of code that works in any machine. This is especially useful in Java and JavaScript, okay? Because they're pretty heavily machine dependent, okay? And this code, okay? So because let's say this is your high level language, you turn it into, this code is called the bytecode. Okay, because let's say you made this in Mac OS, okay, and then if this is compatible for Mac OS, if this is compatible for Mac OS, for Windows, this is not compatible, okay, but this bytecode will work with both Windows and Mac. Bytecode will work for both Windows and Mac. So it allows the production of a bytecode. And also this, oops, sorry. Also makes translation faster. The overall translation of the program, the translation speed of the program also increases thanks to the use of a bytecode. All right, thanks to the use of a bytecode. Now, in our A2 levels, we go ahead and extend the idea on the translation algorithms and translation programs, okay? Because we specifically take a look at the stages of translation, okay? So we specifically take a look at stages of translation. All right, so stages of translation. Okay. So stages of translation can be divided into some following steps, okay? So what are the stages of translation? So let's first try to understand what is meant by stages of translation. Stages of translation kind of is like a method, okay? It's a method on how programs are translated, like a sequence of steps, because the computer cannot directly understand your high level language. It needs to go through some certain steps in order to go ahead and translate the program. So the first stage of translation oops. Okay, so the first stage of translation is lexical analysis, syntax analysis, code generation, and finally, we've got code optimization. So these are the 4 steps that are maintained while translation takes place. And each of the steps occurs sequential. So let's talk about lexical analysis. So what is this lexical analysis? Okay, it is a simplification of the code. That's it. Into hexadecimal. You can kind of understand this by this particular pattern. Okay, so let's say you've got a code print hello world in Python. All right, and we can say that print right over here is a keyword of the program. Okay, and this hello world. Okay, so print is kind of like a function. Okay, it's built into the program. This print is built into the program, and hello world is the task of the function, the input of the function. So what lexicon analysis does, it detects keywords. Okay, so these the print, let's say this print, which is a built-in function of the programming language, what lexicon analysis does, it identifies keywords and it identifies symbols. Okay, so why do I refer to them as symbols? Let's say we have a assembler. Okay, in an assembler, we use something called the instruction table, right? In an instruction table. So in an instruction table, in an assembler, let's say in your assembler, the instruction table states, let's say you've got LDD, you've got LDX, you've got LDI, and these are stored information in the computer. So when you actually solve assembly languages in AS, which you also have to do it in A2, you had some data about all these. Okay, these are fixed standards, right? Fixed. These are fixed standards that the programming language follows. Okay, this helps the computer to understand because these are represented by, let's say, a specific hexadecimal code like 51, 52. This is, let's say, represented by B2, certain hexadecimal codes. So just like that, this is the function of lexical analysis. It detects keywords. Okay, so this print is a keyword, and the hello world is like a symbol. Okay, and for each programming language, there is a predefined set of a keyword table. Okay, there's a set of keyword tables and a set of symbol tables. So let's sort of understand what these actually mean and what they actually are. Okay, so keyword tables and symbol tables store specific values. Okay, because if we need to convert print into, let's say, hexadecimal code and store it in a register for the computer to understand, the same goes for the hello world, because if hello world is a variable, it goes. Now if you actually notice, print is a keyword or a function of the program. Let's say if you're working in Python, print is something that's built into Python, right? And Python knows itself. The computer also knows, like when you have the Python programming language installed, the computer knows that what print actually is. So basically, it's like a method to teach the computer that what print means for Python, right? It's what only this is the only thing that Python understands. So these are fixed, okay? So keywords are pretty much fixed in a programming language. So in a keyword table, the values are fixed. In a keyword table, okay? In a keyword table, the values are fixed. You don't need to assign it. And for a symbol table, the values are not fixed. Why isn't it not fixed? Because obviously the computer doesn't know what you want your program to do with, right? You can print a hello world. You could have written input and then taken input from it. So these variables, okay, like basically stuff like variables, then the declaration of constants, because print hello world, nothing is going to be changing the hello world when you run the program unless you actually edit the code of the program. That means hello world cannot be changed by the user if they don't have access to the code, and only the programmer is going to be having access to the code. Let's assume that. All right. So the thing is, these are kind of like constants. Okay, constants set up by the user, variables set up by the programmer, a constant set up by the programmer or the user. Stuff like these are not fixed. So you need to fix it by yourself when the interpreter, the compiler, or the translation software is performing lexical analysis. Whereas in print, let's say this is a keyword, it's already fixed. So it literally just searches for keywords and the related function to the keywords, and also what parameters the keyword is taking. Like print is taking this parameter, and the function or the work of print, I mean, sorry, not print. So the work of print is to go ahead and kind of print it in the terminal. So it's job. Okay. So keyword tables help the computer to kind of go ahead and arrange and make a simplified version of the program. Okay. So it stores reserved words. Reserved words are like the keywords, print, input, all right, some stuff like that, some built-in functions in Python. The operators used. Now, what are operators? Well, operators are basically symbols: addition, subtraction, multiplication, division. Mod, I think in Python, the symbol for mod is a percentage, stuff like that. All right. So the operators used. Oops. The operators used. And finally, matching tokens. Okay, so what are tokens, or what are tokenization? Okay, what are tokens? Well, tokens are stuff like this. Let's say you are writing a code for count 1, 2, 10. This 2 right over here, all right, this 2 has it's not like a function, right? For means a function, it means a loop. What does this 2 mean? It's not a particular function. It just tells it that from this to this, it defines a range, it defines something. It's not performing any particular job. Like the task of for is to let the computer know that there's a loop coming up in this program. 2 doesn't do anything. 2 just tells for what to do. So these sort of things are actually known as a token. All right, this is known as a token. Now, these tokens are assigned specific values. Okay, for you're also going to be having a token. So what is a token? Tokens are basically like a value for these, all right, because the computer is not going to be going ahead and understanding what this is. So for this for will have a token. Let's say the token for is going to be 10. The token for 2 is going to be 1b. Let's say the token for this symbol is going to be 2f, stuff like that. So these numbers are referred to as tokens. So basically, the only task of lexical analysis is to go ahead and perform tokenization. Okay, so this is the main task of lexical analysis, is to perform tokenization. So by definition, this is to perform tokenization. All right, so what are symbol tables? So symbol table contains names of identifiers used, the data type of the identifiers, role of the identifier. Now, roles and data types are pretty much the same thing, all right? But it is a mark scheme point in some years that you actually write it as a role of the identifier or the data type. They're going to be giving you location, address, marker of a constant, all right? Stuff like these are stored in symbol tables in a program. What does it mean by a marker of a constant or a location of a constant? Well, let's say there's a constant value. Let's say the value of pi. It's constant everywhere. It's going to be used in the program. Pi is never going to be changing. So you define a constant. Let's say constant pi, and it has a value of 3.14, and the location of that constant can be stored in a symbol table. Now, for the syllabus for lexical analysis, we're going to be going ahead and learning a very basic format of lexical analysis if you really want to understand lexical analysis. All right. Okay. So now we need to first of all, now the lexical analysis that we are going to be studying for the syllabus is going to be a very simplified version. It's not going to be the version that actually occurs in a real life scenario. We might be given a short and simple pseudocode, and we need to go ahead and perform lexical analysis on that one. All right. So let's say, okay, now we need to understand that how keyword symbol table work to translate the program. All right. So the first stage that they're going to be performing, okay, the first step is keywords are looked up in the keyword table. So let's say the compiler is going to be going through, or the interpreter is going to go through lines of code. Obviously, we're going to be performing a past paper to kind of go and understand how this actually works, but it goes through line by line, and then it kind of highlights, it kind of picks up on, let's say this was a keyword, this was a keyword like for, print, then let's say we've got input, then let's say we've got return, stuff like these. These certain type of keywords are picked up and looked up in the keyword table, like the token of those keywords are looked up, like the value that these keywords possess. So the next thing definitely is going to be keywords are then represented by tokens. Are then represented by tokens. You replace them with a number. The next thing is identifiers or variables, whatever you call them, are looked up in the symbol table. Remember, even in assembly language, we studied about symbol tables, stuff that we make up, all right? Like we give some symbolic base addresses for assembly language. We don't give an absolute address, all right? So these were then performed using a symbol table. This is the same logic. Identifiers are then converted. This is a very important word, all right? Converted to tokens. Why are they converted? Because again, identifiers are definitely not going to be fixed. All right. So we assign them a value, a special value that is not present in the keyword table. Okay, that's the job of the programming language itself. Whoever created the programming language, they created a syntax, they created some rules, and they created their own keyword table, and that programming language became popular. It's something like that. So these identifiers, or the identifiers are then converted to tokens, and these tokens are actually set up based, like these are kind of set up on the spot because these are not present, right? These are something that we are defining. Whereas for keywords, these are reserved words. You cannot use them. Like you cannot name a variable print in Python because print is actually a function in Python. You're going to get an error. And finally, all of these are used to create a series of tokens. By following all these steps, all right, a keyword table and symbol table work together to go ahead and perform lexical analysis. Obviously, we're going to be taking a look at a question. Also, the lexical analysis stage and comments. White spaces literally means like you're skipping a few lines to make your code look a bit neater and stuff like that. It's something like that. Those extra spaces are not needed with the computer. So lexical analysis removes that. This is unnecessary. The computer needs to process these extra. And then like comments. Comments are for the programmer's understanding. It's not for the computer. So they just remove it during lexical analysis. Now let's go ahead and take a look at how lexical analysis can be performed and how it is generally performed. Okay, how can you expect a question paper? All right, so let's take a look at this particular question. Entries in the symbol table are allocated tokens. These values start from 60. So this is something that depends on the programming language to programming language. Okay, let's say for this pseudocode, in pseudocode terms, let's say this was the program, actual programming language, the tokens would start from 60 as soon as they encounter something symbolic, something that's defined. So see, let's say counter is something symbolic. This doesn't exist in the program. It's pseudocode. Counter means it's a variable, right? We're assigning it a value. That means it's a variable. Input is a pseudocode word. Repeat, because these are in all caps. Counter is not a pseudocode word. So the thing is, counter is going to be a symbol. So see, in this complete a symbol table to show its content after lexical analysis. So in counter, you can see the value is 60, and the type of the variable is going to be it's a variable. The type is a variable. So these are going to be the questions that you might come up in the exam. Okay, this is actually from a past paper. Also, one thing, if you want to show it to you, okay, let's have a look at this. We need this. Oops, sorry. Paste this. All right. This is a symbol table. Okay. Sorry, this is a keyword table, not a symbol table. Okay. A compiler uses a keyword table and a symbol table. Keyword tables are something that is reserved. All right. These values are pretty much unique, and these will because see, the keyword table, let's say, ends in 53. See, this is a very simplified lexical analysis. You're not going to be given complex Python lexical analysis or anything like that, okay, in your exam, in the paper 3. And lexical analysis is not a part of paper 4, it's just a part of paper 3. So in a paper 3, you can look at these keyword tables because it ends at 53. So very safely, lexical analysis symbol table can start from the value of 60. So how can we go ahead and perform lexical analysis? Let's have a look. All right. First task is going to be looking at the pseudocode. Counter is going to be a symbolic thing. Okay, this is defined. So what you go ahead and first do is you go ahead and let's mark out counter with red. Now this arrow, okay, this arrow is the assignment symbol of the pseudocode. See, it's present in the keyword table. It's fixed. That means we don't add it to the symbol table. We ignore this arrow for now. 0 is a constant value assigned by the user. Again, this is going to be something that is user defined. That means it's going to be going in the symbol table. Are we seeing 0 in the symbol table? No. That means our task is going to be to go ahead and take 0, assign it the next value after 60, which is 61. Because as you can see, the question says, does it say anywhere? Yeah, there we go. It does it. These values start from 60. That means it's going to increase sequentially. And 0 is a constant value. No one's going to be changing 0. So this is going to be a constant. Remember, constants are not the only things that are like defined as constants, right? It can be anything. A value that doesn't change, that's a constant. Input, again, it's a full capital word. That means it's a reserved word by default. And you can also go ahead and refer to the keyword table. Again, there you go. There is input in the keyword table. If you're still confused that it doesn't really exist. Okay. This question is actually arranged in this pattern. Okay. Like this is there, and then this is over here, and this is over here. I'm just pasting it randomly in my whiteboard just to show it to you. All right. So if you come across the next word, you can see the next word is password, which is not something that's present in the keyword table. Again, you can look at it if you're confused. So that means we can go ahead and safely write or safely detect the word password. And password, that means it's going to be the value 62. Again, input password. Password is a variable. It takes the input and stores it in the password. So it's going to be a variable. All right, then you go to repeat. Repeat is something that is kind of like fixed, right? It's not going to be going ahead and kind of going anywhere. And again, repeat is a fixed pseudocode keyword, so it's present in the keyword table. It's fixed value. So we ignore repeat. If, again, it's a reserved word. If statements, and it's also a part of the keyword table. So we don't put it in the symbol table. Now, password, again, is something that is user defined. So that's the time when you go ahead and look at the symbol table once again. Is password already present in the symbol table? Yes, it is present already in the symbol table. That means we go ahead and ignore it and go to the next word, which is this symbol right over here, the not equal to symbol. Not equal to symbol is also a reserved symbol. You cannot use this as anything else, and it's also present in the keyword table. We ignore it. Cambridge. Cambridge is a word that's assigned by the user. That means yes. So we ignore this arrow over here. And password, obviously, it is already there. So we ignore it. Okay, Cambridge. And remember, Cambridge is a constant and it's a string. So you need to put it in double quotes. It's going to be turning into 63. And this is, again, a constant value because Cambridge isn't changing in the following lines. Then statement is once again a reserved keyword. So I'm highlighting it with red. Again, if you don't think it, if you're confused that is it really a reserved keyword, then definitely take a look at the keyword table, which is going to be always given in the question. Input is also a reserved keyword. Ignore it. Password is already present in the symbol table. We ignore it. End if is a reserved keyword for an if statement ending. You're confused, end if. There you go. It's present in the keyword table. So you go ahead and ignore end if. Counter, okay, this is a user-based something, so it's a symbol. That means counter is already present in the symbol table, so we ignore it because it's already present. Counter, again. Now, before that, we've got this arrow symbol, which we also encountered before. This is based for the programming language. This is present in the keyword table. We ignore it. Again, counter, it is already present in the keyword table. So in the symbol table, we already did it once. Then this plus sign is also an operator, right? Remember, we wrote it as a note that keyword tables have operators, plus. So what we go ahead do is also ignore the operator. And again, anything that's present in the keyword table will never come to the symbol table. Then you've got a 1. It's again a constant number, right? So what we go ahead and do is we write 1. It's going to be 64, and that's a constant. Now, one more thing in the question paper that you are going to be given spaces as many as you need or less than that. That means if you're seeing that something is crossing the given amount of spaces, you made a mistake. So it's time to recheck. So until is again a reserved keyword. It's a ending statement for the ifs. Again, until is also present. There we go. It's also present in the keyword table. So ignore it. Password, again, we actually came across this before. It's a symbol and it's already present in the symbol table. Ignore it. We've got equal to. This is a reserved operator present in the keyword table. Ignore it. Cambridge, we already have it in the symbol table. Then again, output, reserved word, counter. Counter is already present in the symbol table. All right. So there you go. You have secured 3 marks in your examination. And that's how a symbol table and a keyword table works. Again, the computer does it on its own. They have their own registers for it. This is the task of the computer. The CPU does it and stuff like that, right? So this is the method of the computer to kind of simplify this program. Now the computer knows the differences between, okay, this is what the user has defined, and these are what the programming language is. Now what the computer does is in a register, in a hexadecimal register like this, it serially and sequentially goes ahead and arranges the values. So how is it performed? The output of the lexical analysis stage is stored in the following table. Each cell stores 1 byte of the output. So everything, okay, everything the computer is going to be performing is an output, right? Maybe it's not displaying in the monitor in front, but definitely that's an output. So what we actually do is, let's say counter. Counter has a symbolic value of 60. So we start with the value of 60. Okay, I'm just going to kind of zoom out a little bit so that we can work on it together. Then we've got the arrow. So the arrow has, okay, so I'm just going to go ahead and make a, just bring this and make it very small. Now I can see this. Maybe it's going to be a little bit difficult on screen, so just bear with me. So arrow has a value of 0, 1. So we place it over here. That means 0 has a value of 61. So we go ahead and then replace this with 61. I'm just going to make the ink a little bit thinner so that I can easily fit it. 61. All right, 61. Then the next, we go to the next line. Okay, this is performed from left to right and from the top to bottom, okay? Just like English. Input. So we look at the keyword table because input is not a symbol. So in the keyword table, input has, okay, let's have a look at it. What value does input have? Repeat else. Input, there we go. Input has a value of 51. We replace it with 51. All right, we replace it with 51. Next, we have the word password. Password has a value of 62. Replace it. Next, we have if. Sorry, next we have repeat. Repeat has a value of 4e. There you go over here. Repeat has a value of 4e. Again, stuff will be in the keyword table. Stuff will be in the symbol table. Then next, we have got if. After repeat, if has a value of 4a. Password has a value again of 62. So we write 62 again. Yes, 62 in this case is going to be repeated, unlike the symbol table, obviously, because this is the entire program summarized and squished into this tiny, it's not a tiny register, it's a pretty big register, but the computer needs to simplify things as much as possible for it to calculate stuff. So it's very simplified and stored sequentially over here, right? Okay, so then we've got our not equals to. All right, we've got a not equals to, which is a 0, 4. So it's a 0, 4. Then we've got the Cambridge. Cambridge is 63, so it's 63. Then we've got the den. Den has a value of 4b. There we go. It has a value of 4b. Again, if it's too small, don't worry. Obviously, in the question it's going to be big. I'm just kind of squishing everything in one scene. Then we've again got input. So again, input has a value of 51. After input, we've got password, which has a value of 62. After password, we've got endif, which has got a value of 4c. Endif, there we go, it has a value of 4c. Then we've got 60. So 60 is for what? Counter. Then we've got the arrow. Arrow is 0, 1. 0, 1. Then you've got again counter. So it's going to be 60. Then it's going to be plus. Plus operator has a value of 0, 2. 0, 2. Then 64. Why 64? because we've got the value of 1. 1 is assigned a symbolic value of 64. Then you've got until. Until is for F. So we write for F. Then you've got password. Password is 62. We just go sequentially from left to right and top to bottom. Equal to, right? Equal to, did we use equal to? No. Equal to has a value of 0.3, right? Then you've got Cambridge. Cambridge is a value of 63. After Cambridge, output. Output has a value of 52. And counter has a value of 60. So as you can see, obviously you're given as much of the required space as possible. And this entire pseudocode, okay, this is a big, it's not a big pseudocode, but definitely for the computer, it's a big thing. So this entire pseudocode has become understandable for the computer to kind of squish into it. So as we can see, just as the notes say to us, we use both the symbol table and the keyword table. We first looked at the keyword table and we kind of separated keywords because keywords are separated. We separated the symbols in the symbolic table and made a symbolic, see, identifiers are then converted to tokens. We convert them. And then all of them are used to create a series of tokens, right? So these are all the series of tokens that are stored in the register, and it becomes easy for the computer to understand. Okay, so that's the overall idea of lexical analysis. Okay, we've got our symbol table and we've got our keyword table. Keywords are reserved words and operators. Symbol tables are things that we make it up. All right. And lexical analysis is just used to make, it's just used to perform tokenization, all right? To make the program simple for the computer to understand, and by separating out what we are defining and what the computer already knows. So this is something that the computer already knows. This is something that we are telling the computer to, or basically the input to the functions of the built-in programming language, all right? So that completes the first stage of our journey. We have completed lexical analysis. Oops. So in the next video, I'll be starting to talk about syntax analysis. Oops. All right. So yeah, if you do want to take notes, then obviously I will recommend you can take a screenshot from here now. And then you can pause the video and take a screenshot from here. And finally, pause the video and see how the question was actually performed. With that being said, I'll catch you up in the next video.